morning. Let's get out Kinetics 1. And then you should have 2 sheets. All right. So, I'm opening it up to questions to get you going through tonight for Kinetics 1. E?
Yeah.
God, I gotta do everything for all of you?
Yes.
So this is just a relationship. If you ever want to compare anything in chemistry, you compare it using law ratios and moles. So if I'm saying that this is the rate of NO, it's asking what is the rate of the other two. I'm not saying make them equal, I'm saying what is the rate. So, I'm sorry this is really large. This is of NO. So for every 2 moles of NO, I have 1 mole of O2. So then basically it should make sense that shouldn't the consumption of O2 be half of what NO is, because NO is a 2 versus a 1, right? And then you just fill in the blank on that one, of course. For the other thing, for the consumption, you'd say 2 moles of NO. And there it is, NO2. And then the difference is, if you want to be real technical, is for this answer, you should have a negative because they are opposites. What do I mean by opposites? They're on opposite sides, right? Although the rate is the same, one is being consumed, the other is being produced. So I did both. You do 2 T-charts. I just showed, like that's the second one now. Right? It's just a 2 to 2 or a 1 to 2. And I hope that does make sense that this would be the same, right? 2 over 2 is 1. It should have the same rate. It's just being produced instead of being consumed. That's all. So just trying to show you something that you really actually already know. You just probably haven't thought of it in these terms. Is that when you talk about rates, the mole ratios carry through. So if it's 2 to 1, the 2 is going to have a larger rate than the 1. That's all. All right, what else? I've already answered like 3 or 4 this morning, which was awesome before school started. Yeah, here's
What are the
sentences.
No. Labels. What do you label your answers?
Like for the K?
Yeah.
Let's cross that bridge in a moment, but everything else. So we're talking about units. This chapter, units are vital. Let the tables help you. So like these are concentrations, and then this is your rate. So rates are either concentration over time, and you're going to be careful today. We're going to make sure, is it seconds? Is it minutes? Usually we don't do a reaction in hours because that's just ridiculous. Because if you ever get a time of 0.0014 hours, I have no idea what that means. If you know what that means, that's fantastic, but I don't. Or, as you see on here, when it's written like this, what that means is that. Well, what is that? That's moles over liters, that's molarity over time. So that's your rate. So utilize the table for now. If you're having questions with the K part, I'm going to hold off on that for 1 second. But I will tell you how K is solved. It's just looking at all the units and what's canceled out and what isn't. And we'll take a look. What else? Like finding problems. A lot of people have questions of how am I supposed to isolate which reaction to what, but I'm not just going to go off and do. Max, you got it. Come on, you're halfway there. Finish it off.
Four number or letter A.
On number 4?
Yeah.
Okay. Look at that, I'm all ready for you. Okay, so when you have 3, we have 3 things. This is like saying A plus B plus C equals something. I only care about reactants, okay? So how do I find the order? What you need to do is, in this one, I need to find something that changes. Actually, A's of the 3 is the most obvious. The other 2 are actually really hidden. See how in this experiment 1 and 2, these don't change? They don't need to be the same number, but they both can't change at all. So this didn't change, this didn't change, so this did not affect the change of rate. You're still sitting here like, I don't know what you're saying. When we change concentrations, the rate of the reaction might change. So I don't want the rate to be affected by ones I'm not looking at. So by not changing it, they don't have that effect, but this does. So for letter A, for example, I would do experiment 2 over experiment 1, and then I would put it all in there. We'll just do one more quickly. What would I do? You help me. For letter B. So how do I isolate letter B but not having A and C change? What 2 experiments, if anybody already found this?
Experiment 3 over experiment 1.
3 over 1, let's take a look. I haven't looked yet. 3 over 1, so 3 over 1. Okay, so that changed, that's great. Oh, that didn't change, that's good. Oh, that didn't change, that's good. Right? The one I want to look at needs to change, all the other ones can't. And personally, I would put the larger value over the smaller value, not experiment number, actual concentration values. Right, so I do want to just do one of these. We'll do A. Max asked for A, so we'll do A. Do what he wants with this. Here we go. So this is of the concentration of MnO4 minus, and then we're going to do the rate.
Find the rate.
Oh, wait, no, then you have to use others.
So what is where are the rates? Okay, close. Max, maybe this was actually your question, was how the heck do you execute it after you get the math? Let's take a look. So, this is a great thing to bring up. It's not clean. It's not a 2 and a 2 and a 2 and a 4. This means you have to understand what you need to do with the powers. 2.5 to the what equals the other one. So all I got to do is 2.5 caret and put a 2 there. And again, you got to understand that sometimes this is lab. These are lab values. So if I square that 2.5 squared, it's going to be 0, 1, or 2. You're starting to, let me try a 3, let me try a 4. You are way off center. Okay? So if I do that, 2.5 squared is 6.25. That's close enough. And I know that's not, some of you are like, that's not close enough. It's going to be as close as it's going to be, because 2.5 to the third, we're in the 15 range. So this one must be second order. Because 2.5 squared, always what the change in concentration to what power has the effect of my rate. So, very good question. If it doesn't come out clean, that doesn't mean anything. What I would have been scared about is if this came out clean and that didn't. You're like, whoa, 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 what? I have 2.5 and then I have a 4 here. Like, that's not making sense. So if they both don't come out all that nice, it's actually probably better than if one did. Good. Okay. Great question. So, for example, let's say that you did the concentration. I'm making up values here. Let's just say this is a 2 over 1, so I got a 2, okay? And then my rate, whatever it was, let's say it was a 2 and a 2. Oh, my rate's a 1. Your rate's not going to change, so that means that's a 0 order. So let's just pretend I found out that this is a second order, and this was a first order, and this was a 0 order. I'm making 3 up. Okay, I found that in a problem. What's my rate law look like? What I always do is I write rate equals K, and then if you weren't thinking first, you put these in here, and then you go, oh, well, A is a second order, B is a first. I don't really like writing a 1, but for right now, I'm going to do it in a different color and just act like it's there. You can say, well, C is a 0. If I were doing this officially, and as you see this down the road, this is what it will actually look like. That would be my final rate law, technically. So if it's a 0 order, it doesn't have any effect on the rate, so it's not needed in the rate law. So that's technically the answer. If you did put a 1, you did put a 0 right now, we're okay. But eventually, Let's try to get a little cleaner. Any other questions? Because this is important, and this is, to me, something very manageable that we can handle, I hope. Gave you basically 3 problems, right? And if you mirrored that off a problem for letter A, then you'd be for number 1. What's it?
So, just like A in general, I'm like confused on like what experiments you're supposed to do.
Like which ones? Yep. So, do you have one that you want to run into anywhere? Number 2? So, let's look at letter A on number 2. So, I'm just going to do one more of these. It just says find them for both. So, if I did NO, what I'm wanting is finding somewhere where they changed, but then the other one doesn't. So right away, I see that these don't change, and this does change. So that's why I want experiment 1. The one I'm looking at needs to change. That means all the other ones cannot change. So in this one, here, this would be 1/2. And why 1/2? Because I want the larger value over the smaller one. And these don't change. What would be, anybody, what would be the experiments I would pick for the other compound to figure out the order? For number 2.
3/1.
3/1, let's take a look. So, I'm going to disagree. You're close.
Oh, I'm looking forward.
3/2. The reason why is that these don't change, right, and this does. Okay? So, you're isolating the one that you want to see. I'm going to repeat it again. This isn't making sense. Why am I doing that? Because the one I want to find out of the order is how is it affecting the rate? Well, I don't want any of the other ones to change, or then I don't know that that is the effect that it has on the rate by itself. In any science, one variable at a time that changes. So then you see the effect that it has. You have 17 variables that all change. How do you know what the effect is? And that's why some things have gotten so political. Because how do you convince environmental issues or economic issues or anything, and you say this is happening, when there's like hundreds and hundreds and hundreds of things that all contribute to an overall solution or a problem. And any one person can say, this thing is causing it or this thing isn't causing it, until you can actually say, none of this is changing, and then we change this one thing. Would you ever know any one effect? So you don't want to get all messed up on a problem like this where you're allowing 2 things to change at once. You'll never know the effect that it has in there. Okay. So, when we're talking about kinetics, we're going to do a lot of fun stuff. Kinetics is about rate. It is about speed of a reaction, slow or fast. Next week, we're going to talk about how we can increase the rate. So I have this cool demo. It's very, very simple. And then I'm going to try another one. I don't know if it's going to work because it's supposed to be cool and it's really, really, really hot yet. Yeah, it's really warm. But indicators are really cool because an indicator can tell you what's present when based on elements that are present or pH. And you know if I'm on the product side of a reaction, if I'm there because of the color, or if I'm on the reactant side, all because you know that indicator changes color at a certain time of pH, again, or of some sort of substance present. So in this one, right now, what color would you say this is?
Is clear a color?
Clear. I'm glad you said that. Clear is not a color. Because this is clear as well. That is clear and delicious. And I got back on it and I'm really upset with myself. Anywho, we'll talk about that later. This is colorless. But I shake it just a little bit. And it hasn't been shaken since homeroom.
Excuse me.
What?
That's not how that works.
And now all of a sudden it's blue. So what's happened is I just caused a reaction. What did I just add? Anybody? Be a chemist. What did I just add? And don't add shaking, because that... Energy, no. So as this sits here, what's going to happen is there's a compound in there that's going to start reacting, and it's going to cause it to go slowly back. I tried it with this one. This is going to be an epic fail. I'm going to do it anyway because I already made the compound. I've never gotten this to work. So there's this one. And if I asked you a color, actually that's kind of a hard question. You're like, I don't quite know what color that is either. But, yeah, this one just has never worked. I'm just trying to distract you from the other one, to tell you the truth. But this is supposed to work. Oh, I saw it for a second. Dang it. It's not working. This one can go to red and yellow and green. And I don't see any of that. I see a disgusting looking orange, and that's about all I see. But what am I adding before we get into today? When I do this, what am I adding? Nothing. What am I folding into the reaction? The air? Gabe? God, even with one mitten, you are good. It is oxygen. I'm adding oxygen. If you saw this, I don't want to show you the balance equation for this right now, but oxygen can be on one side or the other, and then it starts to react and it goes away from the oxygen. And the oxygen, present or not, causes this to have a blue color, or it doesn't. So it's kind of cool. This will last for a good half of the day. And that is supposed to also do that, but it doesn't. Well, it's not just about that. Oh, please work. Kinetics, again, is all about rate. Oh my God, please work.
Please, come on.
It is clear. It's not a color. Okay. Here we go. Dang it. What?
That's not how that works.
That just happened.
Like automatically just changes. Like no.
I'm not going to tell you a lot about this because there are some really cool things that you can do, and for some of you, you might decide to make this as your AP final project. You can make this go to songs and turn colors to different parts of the songs. But here, watch this.
Someone's gonna try. Oh, I like this. Best experience of the year right now.
See how many we can get to turn at the same time.
Chemistry. Mine was the feed. Mine was the feed you water.
You're a jerk. Oh shoot, I didn't do this right. It's not gonna... See, so what you can do is you have it timed right, and then as it's going on the beat of whatever you want with the song, it... Oh, what? And that was supposed to happen. Shh. Anyway, that's all about kinetics and how much is present in collisions. We're going to talk about that later this week. And the molecules actually have to collide, and when they do at a certain amount and a certain rate, they will create a reaction. Might as well use this up. That is not what I was hoping for. Oh boy. Dang it. And there you go. Okay. So, all right. So today, you have two sheets, and I want them out simultaneously, okay? So you need them both on the same side. What we're going to need, and we're going to need to do this in an organized fashion, and I don't know how many I can, if it's, you might have to share with someone. I brought some graphing calculators. So if you have a graphing calculator, I'd like you to get it out. If you do not, we're going to try to do this in an organized fashion. I have 6 that do not have batteries, but I brought my own batteries. You need to make sure that those batteries are given back. So those are the ones with the rubber bands. I should have said this right at the beginning. I have my own 2 as well that I'm going to lend out. So that's the ones with the gussie on it. So In general, actually what I do need to know, because I'm going to work with the math department on this. Starting tomorrow, just keep your hands up for a second. Who's going to need a graphing calculator for this chapter? Which is totally fine. Just keep them up. I need to get a good number so I can supply it. That's good. So, if you need one, this is going to work out just fine. I have 24 right now. Only 22 of you raise your hand. So, if you need one, let's do this let's just come down this way. You come back the other way. Grab a calculator, and then head back, please. You can grab one with the rubber band. I'm going to give you the batteries, and I need you to give them back to me if you grab one from the rubber band area, and then you're just going to hand the batteries back to me at the end of the day, too.
This one works. This is actually the one used in class.
Katie's using 2, 1 for each hand.
Yeah.
So who's lazy? Who's not coming down? Oh. Okay, if you need one from the rubber bands, just grab my fork. I know no one will until they have to.
I don't want to go back.
You get new batteries. Oh, that's like
I feel like these are like the same thing. What is that?
I got
It's the same bar. It's the same button. It's just I
Okay. Make sure it's on. If you don't know, you hit second and the up button, and you can get it darker or lighter. Second and up, second and down. Okay. Just if it's not working. All right. So here we go. You have your 2 sheets out at the same time. So what you guys just did, and what we've been working on in Kinetics 1 is called a differentiated or differential rate law. And if you look, I have it on the note sheet that looks like a notebook piece of paper. It shows how the rate depends on concentration. So I was showing some different kinds of concentrations. If I watered those down, I could get them to react at different times. Let's load up those batteries. But what we're going to look at today is an integrated rate law, which is dependent more on time. So how long the reaction is lasting, we can determine some different things with concentrations and things like that. So instead of, I'm something wrong with it?
Yeah.
What? Did you hit second and up? Maybe you just need to get darker.
You can make this right too.
What do you have?
Okay, guys, this is you gotta stay with me here then. So I've given a table that gives you a bunch of information. Now, I need you to know that most of this is on your orange sheet, which is very, very, very good. And we'll look at that all later. Okay. But today, what I need to start going through is having you understand how this all works. Okay. So, what we are going to do and what our goal is we need to look at the relationship of our concentration versus time, and our goal is to get a straight line. So y equals mx plus b, that's what this is all about. Y equals mx plus b. So what I have a problem here, and then a bunch, and I have it right here as well, of screenshots. And I'm going to help you kind of go through that. So you write as little or as much as possible, but you need to understand that in 2 days from now, when I'm not here in front of you helping you, you should be able to look back at your notes and go, oh yeah, that's what I need to do. That's the screen I'm looking for. So make notes. Just because I'm not writing something down, if you're like, oh yeah, I should probably know that I need to push this or that. Be involved in making sure that you have that down for you. So here it is. First, we need to get the data in. So what we're going to do is we are going to hit, shoot, I don't have my own notes, which is okay. I just don't want to say it wrong before. Okay, you hit, so to get to here, I'm on this sheet, you hit stat. Now if you have a different calculator, I will help you with that eventually. But the minute you hit stat, you should see that. So you want to also be involved. So if you hit stat, you should see this. right? And then you do want to hit edit. So when you hit edit, I believe, when you hit enter, doesn't it go to that table? Yes. So when you hit enter or edit, it should take you to this. Do you see that? You should see that screen, right? Okay, if you do not or you have a different calculator, I will tell you, I will go through all this personally with you if you have a different kind of calculator. There are a few different ways that this looks and it will all still work. Okay, to the side of this, what I want you to understand, we're going to write this right now. So write these four labels. You're going to have 4 columns, okay? If you repeat this the same every single time, it's going to make more sense. Now, if you have your own calculator, you set this up once, you're going to be fine. If you're borrowing one, it does take a little extra practice. What we are going to do is for this first one, it's always going to be my time. So that's going to be my time. Okay, then L2 will always just be my concentration. And by the way, that's going to be, I'm going to give you all the information you need. That's going to be 0 order. If you look at the top of your sheet eventually, and the other one, I wrote 0, and it's a concentration. Okay? The second, I always view this as the first column of concentrations. This is ultimately going to be natural log, that's ln, concentration. And I don't expect that you know all of this yet. And some of you do have a little bit of an advantage, depending on what math you're in, but none of you are at a disadvantage. I'll say that. That's going to be my first order, and then the last one's going to be 1 over concentration, and that's going to be second, and I'm going to show you how to do all of this. So that's what this screen is going to represent for us. Okay? What's nice is that you don't have to input all of this. You only have to input some of this. So what I'd like you to do right now is we are going to take, I'll give you a second to make sure you write this down. Again, my goal is to do 1 problem today. We're going to fill out that. If we have extra time, I have another problem to practice, but we don't need to necessarily. Are these the same values on that other sheet below? I think so. Okay. So do you see how I have that chart written? That is mirroring what I'd like you to do on this sheet, if you could, is write L1, L2, L3, and L4. So you also have an understanding going back the other way. Please understand that I have a table on the top, and then we're starting an example problem. I think the best way to teach this for you is to just go. So what I need you guys to do now is when you are ready, I'm going to give you a moment, is go back into stat and edit, and in the first column, put 0, 1, 5, 10, 15, 20, and go to the second column and put all of these values. So I'm going to give you a minute to do that. Jacob, is it not working? Come on. Oh, you batteries. Your batteries are good.
Yeah.
Get new batteries. Well, look on it. Yeah, please, because you want to be involved. Get those numbers in. They're on your sheet too, so. Okay, so some of you might not have all of those, so what you need to do, it's really weird, we need to delete them all.
Where is the Sol's box on this calculator button?
Actually, card calculator has that. Who's? What does he have? Like a 25 calculator.
It's really, really nice.
Like he usually knows minutes. Like if he can't know, he's not. Why is he at 20?
Well, I think his dad probably had one. Like, his dad's here, obviously, he has not really
Carter.
no.
He just picked it up. He went to Sorry. Meteorologist school.
That's so science.
That's prediction.
I have to ask that.
Yeah, I understand.
Very nice.
Okay, in a moment you should be basically having that done, okay? You have it, okay, so right now you might need to just, we'll learn it all, I would have to, I'm gonna have to go through it with you a little bit. We'll figure it out. Almost every one of them just has a little trick or a different approach, so just, you and Kai just do it together. Okay, so now what you guys need to do, again, try, this is hard, and please understand that if you're running into some snags, it's difficult for me. But we'll do the best we can. If I take a normal calculator, just so anybody have one else, if I took 0.3 and I took the natural log of that, I should get this number. Now you don't have to write that in yet. But what we're gonna do, whose is this? Is that I don't need to type all these in. I can let the calculator do that for me. So what you do is you need to highlight you bring it up and you highlight L3, so you actually push up, and then the cursor should be blinking on the bottom. And what you do is you type in natural log. Stay with me, I will help you. Don't do anything yet. If you look at your number 2 button, do you see in yellow that it says L2 above it? So what you're going to do, try it once, you'll know if you did this right. You highlight it, and then on the bottom, you hit the actual LN button, which by the way is to the left of number 4. If you hit LN, and then second, and then the number 2 button, hit enter, it should all fill in that column. And the first one I see is negative 1.204. If you did that right, which is what I just figured out. If you did it right, it should say negative 1.204. What you do then, same thing, you highlight 4 and you put 1 over L2. So you divide 1 over L2. So go up on the column, put 1 over L2. And if you do that, just so we are all, calculator. Your first answer should be that, if you did it right. Yes? So you need to do 1L1. So it's the here. So what you need to do,
It's untouched by humans. They touch the machines, but they don't touch the water. Shift the water to the way. This one, yes. I mean, it's like here's a
so just when I say
it's a hand pump.
just be patient with me.
He's got a bowl, wooden bowl.
Bear's dad, she goes to your after season.
Sam, yes.
I was doing the internet.
You can also?
What else? Anybody else? Wait, you need to have these numbers on there, and then it fills it.
Yeah.
I'm sure it's not.
Oh, Sam. Unless it was
Okay.
but I don't have.
Okay, I haven't done this for a year, so it's not like I do my integrated rate log club every Wednesday night. It's Thursday nights. Okay, so now what we need to do, guys, is we need to plot some graphs. We need to find the straight line. So what I need you to do right now, no matter what, whatever calculator you have, you need to fix something for me on your sheet, because this is wrong. So find the one that has these plot 1, plot 2, plot 3s, please. Okay, and what you need to see, So this first one's right, the second one's right. The last one where it says L1, L2, you need to change that L2 to an L4. Like just draw right over that actual image. It needs to be an L4. Please draw over your image. It should be L1, L2 for plot 1. L1, L3 for plot 2. L1, L4 for plot 3. So let's just write something of what we need here.
It should be L1, L2, L1, L1. Gotta change that one.
Yeah, I never really know where anything is. I just kind of start clicking around and doing
What do you do?
What you need to understand, guys, L4 is your 1 over concentration. The biggest thing I can teach you today is this. Concentration is 0. Natural log is first. Inverse is second order. You need to start getting it down today. Not like, oh, well, I'll worry about it when something else applies. That's everything. Concentration 0. I'm going to say it every day, multiple times. Concentration is 0. Natural log is first order. 1 over it is second. And it's not overly confusing and complicated once you start understanding that. So, because of that, L2 is my 0 order, so that would be my graph for 0 order. My natural log is my first order, so that would be my second plot. And the 1 over that is my second order, which is my third plot. So, how do we find that? What you need to do, and we don't have to draw on every one of these, so that's why, hopefully you have more space than I do. Gotta remember. Yes.
Did you go from the L1, L2 screen to the
I haven't yet. So what you're gonna do?
I know.
Stat plot is in the upper left, right below the screen. If you hit second and stat plot, you should get this screen. Plot 1, plot 2, plot 3, right? What you need to do, and it's going to take a little time, okay, let me steal yours, is that you need to go into the plots. So right now, I believe everyone's, if nothing's different of Caitlin's here, they all say L1, L2, L1, L2, L1, L2. That's what mine says. So I don't need to touch the first plot. So what I do is I go to the second plot, hit enter, and what you'll see is that there's an X and a Y list. Now, I believe if you have a plus, and I would love to see, I see Ann has one, Sophia has one, it might be easier and actually asks you what they should be at, but mine says X list and Y list. It's right here, by the way. Right here. You need to set these to be the appropriate numbers. How do you set it? You do not type L and then 1. You find the L1, L2, and L3s or L4s on the number line with second. So for example, plot 2, I hit second and L3. Please, if you're looking down, look up for a moment. Guys, right here, see how it says plot 1, plot 2, and plot 3? You can maneuver from one to the next without leaving. So after I hit L3, I just go up. A couple things. I would do this type. I'd circle that. I don't want dots. I want it to connect. So when I'm looking at my plots, I want it to connect. So hit enter on that, and then that should be highlighted. You can screw around with pluses or dots or squares and all that stuff. But then I'm going to go up to plot 3, hit enter, and then I'm going to make that L4. You do that one. It's L, wherever the L4 is. And then I'm going to make sure that I have the graph be in a line. I don't think I did that for that one. So all 3 plots should have a line. Go between plot 1, plot 2, plot 3. I all want a connected line. So I'm going to give you a moment. If you need any help,
Mr. Gussie, do we turn it on?
we'll turn them on eventually. Yeah. And again, if you guys understand, some of you might understand this faster than others, that's fine. Again, our goal is to get this one at a time, though. I just want to get one problem in there.
I know I can turn it on, like just about looking like this. Boom.
Okay. Really good. I gotta remember. Is that one of those? Okay, don't hand that one in out. You got it? The yellow one?
Yeah, I'm gonna have to charge my tokens.
It doesn't have to be more specific. I gotta know.
Do you have to turn all the plots on?
Good question. So, check this out. I don't know if you know this as well. If I want to move down here, I want to go like to the third one, I can just hit 3, and I think it just goes right there, like you actually hit the number button 3. If they're all on, it's annoying to go and turn them all off. So you can always hit 4 and say plots off. You only want one of them on at a time. Okay? So what we want to do right now, please turn on plot 1 and make sure the other 2 are off. How do you do that? Literally when you go into it, it's on or off when you jump into the actual plot. So turn on, make sure they're all off, or only plot 1 is on. Okay? So
Really says no.
what we do,
I think that's wrong.
you turned it on. So just plot 1's on. Okay.
What, it has it as if these.
Then guys, what we're going to do is you're going to hit graph in the upper right.
Yes.
Okay, very important. Stay with me.
I just did that. That's what I just did. Right.
If you have a different one, I will. It'll take me 10 minutes, you'll get it. Guys, check it out. You hit graph, then the zoom button's below the screen, and then if you just hit 9, the graph should show up. It's called zoom stat. But if you just hit the button 9, you don't have to scroll down to it. You should just be able to hit zoom and 9. What's going on here?
I'm really not ready to do this stuff. Yeah, I literally just wrote what
You're fine. And you should see a graph right now that looks like that. Right? It's not a straight line. So that means this is not 0 order. So what you need to do, and I'm sorry if I'm losing some of you, but you also can raise your hand and call me over and we can get you right back on track. Go back to stat plot, upper left. Turn off plot 1. Turn on plot 2. Okay? And then what you guys do, if you're like, what do I do next? Graph, zoom 9. Okay, if you don't have one working, be involved with the other person so you see it at least. And zoom 9 then. Then just hit zoom 9. Just hit zoom. And then hit the button 9. Just hit 9. Slap you. Straight line? No. If you're a gambling person, you could say it must be second order. That's assuming you did everything right. That's not a good assumption. So, what I'd like you to do, clear plot, turn off plot 2, turn on plot 3, graph zoom 9. We have one more thing to write, and then we're going to actually do the problem. If we have 10 minutes, we have to do great. Believe me, I don't expect you all to have this down in one step, one time. Turn off plot 2, turn on plot 3, graph zoom 9. Aha, why does it go the other way? So final thing, I'm assuming you have room to write this. Okay, so for this one that we had, I believe it looked like this. Correct? Okay. Why is it going in the opposite direction for the second order? Because second order is what? 1 over the concentration. It's inverted. So it will always go in the opposite direction as the other 2. We will talk more and more about this, that you should be able to recognize if it's a second or if it's a 0 and a first, because the second order will always be going right side up. So in this case, it's a second order because we have a straight line. Okay, so we will come back to this sheet in a minute. But we know it's second order. So let's start doing our problem. All of that was to find the order. But we're going to use it. Believe me, just people have done this before. We get good at it. Let's do the actual problem. Where are you? Here we are. Wait, that's not it. Okay, so A. We're on the note sheet now. Don't clear anything. We need it still. It says determine the rate law of the decomposition of hydrogen peroxide. Let me be very blunt or clear about this. Is that when we're using integrated rate laws, you will only have one reactant. So you don't have to be looking at all these different reactants. So the equation is just H2O2 decomposing, but I want a rate law. So in this case, rate equals K. You always write the compound. There's only one. Now, this is a new. What I'm showing you right now is a new, and then what would you do? You'd put a number, don't do it yet. You put a number right there. So if it was zero order, I could put a zero or then get rid of it, and then rate equals just K. By the way, if you look above, look at zero order. Rate equals K. First order, rate equals Ka, and then rate equals Ka squared. So what am I writing? Rate equals K, hydrogen peroxide squared, right? Because it's a second order. I allowed the graph to help me. Now, we didn't do all of that just for that, but that's all we've done so far. There's more to it. Letter B. Determine the rate constant. Okay, what did we learn about rate yesterday? Rate is the slope. Well, if we can find a straight line, when you look at y equals mx plus b, k is the slope. So what I want is the rate constant. I want to find the slope. So we're going to go back to our sheet. Last image, Caitlin, sorry. You go to stat, and then you slide over to the calc. So that's calc, it's not an actual button, right? And then if you go to the number 4, if you just hit 4, it'll actually do it, which is line rig. That is y equals mx plus b. Now, if you have a plus, this is amazing because you can't make a mistake on this. It will actually ask you to type in your L1s and your L2s and all that. But if you don't, what you do is you hit calc, you hit 4, and then this is the problem. This is the hardest thing to remember. It says, literally, line rig. This is what it says for me. And if you have a plus, it actually asks x-axis, what does it say, x list or x?
It says X list.
Okay, and then y list. Okay, what are we doing? We want the plot that made a straight line. What was the plot? L what and L what? L1 and L4. So you have to type those in. Don't type L and 1. You hit second and L1. But here, you want to type this in. So I want L1. Now, you need to find this. There's a comma button. I believe it's above the 7. You see that? That's not a J. That's not a G either. And then in this case, I want L4. So it should say L1, comma L4. So hit second L1, comma second L4. If it asks you for them, that's awesome. Then you don't have to forget that. If you did not type that in and you just hit enter, it will default to L1, L2. So just understand, it will give you a number. That's what stinks about this. It won't go error. And you're like, oh yeah, shoot, I forgot to do that. You can get totally worked over on this one. To me, this is the single hardest part because there is no clue that you did it wrong. And if you do that, you should get a y equals mx plus b, y equals ax plus b. So which one's my slope? The a?
Yeah.
So, in this case, you gotta look, yours could be different than mine. So it's gonna be 1.188, let's just say that. You need a unit. Okay, check this out. Stay with me, these last 6 minutes are really important. If this is molarity over time, wait, hold on. See the time? It's in minutes. So it's molarity over minutes. Oh my gosh, let me start over. I'm going to try to give you a clue here. If this is molarity, you're squaring that. So don't I need to get rid of one of these? I need this unit over here, right? So I need one less of these. But I need time over here. So what my K does is cleans up the mess or adds things to get the unit to be here. So this times this will cancel or add to get it to be molarity over time. So I need to get rid of one of those, right? So this is how I do this. My unit, this is how I do it, is I flip molarity. So I automatically do liters over moles times the time. And then, right here, this is the trick that literally you don't have to think about then, and you were guaranteed points because you have to get a unit right. If you just write L over mole times whatever time it is, usually it's seconds, this one's a minute, and you do one less than the overall order, it will delete all of the molarities but one. What am I saying? What if you had multiple ones here, and you had a 2, I'm making this up, a 2, and a 1. So that's 5 overall order, right? 2 plus 2 plus 1. You need to get rid of 4 of those 5. So I'd write liters over moles, and I'd put a 4 on both of those, because that's 1 less than the overall order. So because it's second order, I just leave it. If it's first order, 1 less than 1 is 0. So literally, it's just inverse time, because you don't have to get rid of the molarity. And I know right now you're like, whoa, that's the least of my concerns. I'm still worried about second stat plots. I'm just trying to give you the clue and the hint to do that. So that would be my unit, okay? Good. Let's finish up the questions. Did I set my sheet over by groups?
Yeah.
C. What is the half-life? Okay. The half-life, we haven't learned this yet, but I'm telling you right now, a half-life is when I have half of it, how long it took for half of it to disappear. The tricky part is, let's say a half-life is 10 minutes. So after 10 minutes, it's gone. So after another 10 minutes, after 10 minutes, half of it's gone. So what's going on in 20 minutes? Is all of it gone? No, half of that disappears. And then half of that. It's not like, oh, half is gone in 10, the other half is gone in another 10. No, half of that. So 10 would leave the first time, then 5, then 2.5, then 1.25, and so on and so forth. My math breaks down pretty quickly. So, on top, I have some relationships to show you. But I want to show you it in a different way. So this is called an integrated rate law. So, you can stay with me here. Y equals mx plus b. Here we go. Here we go, here we go. So, on the side, if I did this, if that was just, that's my graph. What's my y? 1 over concentration, correct? Right? What's m mean? Okay, that's slope. So what did we learn slope is? It's k, right? My x is my time. And what's b? When it intercepts on the y-axis, correct? Yep. So what that means, it's my initial amount before I start. So what we do in chemistry is you always say a bracket with a 0. The 0 means 0 time. So I'm not trying to confuse you. If you look above right now, you see that equation. If you look at it under integrated rate law, can you just look across and look at the 3? Stay with me, please. Look at the 0 order. What's the difference? It's just concentration, and then the k is negative. Why? Because it has a negative slope, so we have to get rid of that. What's the first order one? Oh, instead of this, it's natural log, and a negative. So if you still remember just concentration, natural log, 1 over concentration for this week, you can start understanding that it all falls in the same concept. So how can I do half-life? Well, I gave you an equation on the top, so we could cheat. And you could literally plug it in. If you look at that, see that T half equals 1 over K with the initial concentration. So let's cheat and do that first. So I'm going to put 1 point. Wait, sorry. Did I do that wrong? That's 1 over that. I'm sorry. Times the initial concentration, which is 0.3 molar. And I can find the half-life. I'm just plugging that right in. If you look at it, half-life for a second order is 1 over K concentration. So I can plug that in. I know I'm getting low some time here. And I get 2.8 minutes. Where am I at? Okay, we'll finish this up tomorrow. What I need you to do is make sure that you have Kinetics 1 completely done. Okay, if you borrowed a calculator, need them back. If they're my batteries, let's set them outside here. If they're not, put them in here. I need 22 back. So focus on Kinetics 1 right now. You can look at lesson 23. We can probably do over half of it already.
It makes sense, but at the same time.
Oh, Michaela and Ann, congratulations. You are actually, I keep forgetting to announce this every week, the Esther winners. You guys were the only group that there was another group that tied, but you all didn't enter it in on the spreadsheet. So by default, you guys won. So.
Default, that's what
Well, not a default. They did what they should have. Please return the calculators.
I was gone on Tuesday and I keep
Calculators, calculators.